Hi guys. So today we're going to talk about equations of circles. Section 10.6 is our last circle section. This will be the last lesson of chapter 10, but it is going to span for the whole week. So both assignments this week will be on equations of circles, mainly because there's so much that we can do with equations of circles, and I didn't want to overwhelm you with all these different question types at once. So we're going to take this lesson slow, but it is our last lesson for equations of, or for circles in general. So there's no reminders this class. Just keep in mind that the radius extends from the center to the edge of the circle because we will need that sometimes. But other than that, I want to jump right into the lesson. So we're going to talk about equations of circles today. Now, when I say an equation of a circle, this is very similar to the concept behind the equation of a line, or slope-intercept form, or y equals mx plus b, whichever version of that you're comfortable with. So this is very similar to that. When you have y equals mx plus b and you plug in values for x and get values for y, if you were to plot those points, you'd have a straight line, right? So there's a similar equation that can be used for a circle. And when you plug in points for this, you'll get points that would graph to be a circle on a coordinate plane. So this is our very last circle lesson. We're kind of taking everything we know about circles and putting it on the coordinate plane and relating it back to the coordinate plane. So I have a couple fill-ins for you. So the equation of a circle, the same way that in slope-intercept form, y equals mx plus b, m stands for the slope and b stands for the y-intercept, we have some key components of the standard form of the equation of a circle. So for the equation of a circle, just making sure my pen's ready to go, we have x minus, and it still wasn't, we have x minus h squared plus y minus k squared equals r squared. So a bunch of letters going on in the equation version. Just know that h, k, and r will be numbers when you have an equation. Just like in m and b in slope-intercept form are numbers. So I have a couple key takeaways before we move on, but the first thing to keep in mind is that HK, the ordered pair, it's a point, is the center of your circle. So that's your center. And then another thing to keep in mind is that R is the radius. So before we get into examples, I just want to talk about a couple key things to keep in mind while you're working through some examples. So the first thing to keep in mind is that in the standard form, the equation is x minus h and y minus k, but notice how positive h, positive k is the center. So your signs will always be the opposite for the center. So if it said x minus 4, the x coordinate of your center is positive 4. And if it said x plus 2, the x coordinate of your center is negative 2. So just keep that in mind. Another thing to keep in mind is that r is the radius, but on the right side of that equal sign, it's going to be r squared. All right. And then finally, you have a squared after your quantities for y and after your quantities for x, and there's always a plus sign in between. So you can use this for all of the practice that you're doing. You can use it for the test that you'll take next week. But just keep in mind that this is what the formula looks like, and that's where some people may make mistakes, is with the signs or with the squared aspect of it. All right. So what I decided to do was in 10.6, I split it up based on key concepts. So for part 1, which will be due Wednesday, I want you to find the center and the radius given either a graph or equations. So you're finding the center or the radius given the graph or equations. All right. So first we're going to start with finding the center. So this is going to be a whole IXL just on finding the center of the circles below. So remember, the center is the very middle point. It will always be marked on IXL. So looking at the first example, my center is that yellow dot in the middle, right there. And that yellow dot lies at the point 0, 0. It's at the origin, right? So my center would just be, 0, 0. That's all. You would press enter, you'd be done, and you'd move on. Now, for number 2, the center is that green dot again in the middle. So we have to find what point that is. So it's over 3 and it's up 0. So my point would be positive 3, comma 0. So again, this is just finding points on a graph. This is very similar to some of the concepts that you might have done with Mr. Green last year in Algebra 1, if you had him last year for Algebra 1. All right. So finding it using a graph is nice and simple. Now, they could also ask you to find the center using an equation. So this is the equation of the circle. Now, for number 3, it says x squared plus y squared equals 36. So I'm just going to write the actual equation of the circle below it, just so we have something to keep in mind. So remember that actual equation is x minus h squared plus y minus k squared equals r squared. And then remember that hk is the center. So when they ask you to find the center, those are the numbers that I'm concerned with. All right, so now looking at my first example, is there anything being added or subtracted to x or to y? No, right? It doesn't say x minus 4, x plus 7, x minus 12. There's no number there. So since there's no number being added to x, the x coordinate of my center is 0. Since there's no number being added to y, the y coordinate of my center is 0. So again, that center would just be 0, 0. So this is what it would look like graphed. That would be the center right at the origin. And then again here, that's the center right at the origin. All right. And then number 4, a little more complicated. So I do have to say, IXL loves to throw fractions into these lessons only to confuse you. It doesn't change the problem at all. So don't get scared just because it's some crazy fraction like 19 over 3. That's not even a common one that we work with. It's totally fine. So again, you don't have to write this every time, but just for our purposes, I'm going to write the actual equation below it. So I have x minus h squared plus y minus k squared equals 4. Oh, not 4. I was looking at the example. Equals r squared. That's the general form with no numbers filled in. Equals r squared. So what I was thinking about is how we don't have to worry about anything after the equal sign. I'm only concerned with what's being added or subtracted to x and what's being added or subtracted to y. So looking at this equation that we're given x minus 19 over 3 squared plus y squared equals 4. So looking at this, I have something being subtracted from x, right? I have x minus 19 over 3. Well, I know that in the standard form, if I'm subtracting h, positive h is the x coordinate of the center. So since I'm subtracting 19 over 3, that means that my h is equal to positive 19 over 3. So we're changing the signs here. And then k, I'm not adding or subtracting anything from y, so k would still be 0. So then my coordinate is 19 over 3, comma 0. So this is finding the center. This is one entire IXL just on finding the center. A couple key things to keep in mind, some common mistakes, because I did pull these straight from IXL, so I did the IXL. And some mistakes that I was making especially is forgetting to switch the sign. So just be careful with that. So forgetting to switch the sign is a common mistake. So just make sure that you keep in mind that it should be the opposite sign. It's very easy to complete the ones with the graph, but then with ones that are like 3 and 4, it gets tricky and it's easier to forget like, oh, that needs to be the opposite sign. So just keep that in mind. So that's the first part of today's lesson. Now the second part of today's lesson is to find the radius or the diameter based on the graph and based on the equation of circles. So on IXL, it's very important to read the directions for each question because one like number 5 could say just find the radius, One like number 6 could say just find the diameter. So make sure you're paying attention to the directions. For our purposes, we're going to find the radius and the diameter for all the questions. All right, so remember, the radius extends from the center to the edge of the circle. So this is a radius from the center to the edge of the circle. This is also a radius from the center to the edge of the circle. This is also a radius. All of those are. Now, it is very hard to find the length of this last diagonal one that I drew. So when you're given a graph, the easiest way to find the radius is to start at the center and go to the edge, but go either horizontally, like the first line I drew, or go vertically, like this line that I drew. All right, so I'm just going to count over horizontally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that right there, my radius has a length of 10. So I'm already halfway done. Now I just need to find the diameter. So a couple ways you can find the diameter. When you're given a graph, you can count from one edge of the circle through to the center to the other edge of the circle, because that would be a diameter. Or keep in mind that the diameter is equal to 2 times the radius. So it's up to you. There's a couple ways that you can go about this. Me personally, I would just take the radius and plug it into this equation. So it's going to be 2 times 10, which is 20. So my diameter is 20. Now, you could also count. So if you counted from here all the way over, you would count 20 units. So either way, you'll get the same answer. I just think that this is actually faster than counting and more accurate because you won't forget a step along the way. All right, so that was the first one. Number 6. So again, we're finding the radius and the diameter. Easiest thing to do is to go over horizontally or up vertically. So for our purposes, I'm always going to move horizontally. So I want to start at the center and go straight to the edge, following that line. I want to count how long that is. So if I count, it's 1, 2, 3, 4, 5, 6, 7. So that means that my radius is equal to 7. Now again, to find the diameter, I could also count this way. It would also give me 7. And then the entire thing would be 7 plus 7, which is 14. Again, using the formula, for those who are very formula oriented, you would do 2 times 7, which gives me 14. So my diameter is 14. All right, so that's when I'm given a graph. Now they will also give you an equation, just like some of the other problems from the center. When they give you an equation, keep in mind we are only looking for the radius or the diameter. So I'm going to write everything out so we have it. So remember, it's x minus h squared plus y minus k squared equals r squared. Now again, I'm only concerned with finding the radius here. That's it. So I'm only concerned with what comes after that equal sign on the right side. So in the general form, it's r squared. In this example, I have x squared plus y squared equals 81. I'm only concerned with that 81. So since it's equal to 81 on the right side and the general form is r squared, I now know that r squared is equal to 81. Now this is a common mistake. So r squared equals 81, not r. So 81 is not your answer, so be careful with that. But we have one step to solve. So we have to take the inverse of squared in order to get r by itself. So that would be square root. So I'm going to take the square root of both sides. On the left, the squared and square root, they're inverses of each other, so they cancel. And then on the right, I'm left with the square root of 81. And the square root of 81, you could plug it in the calculator, or maybe you know right off the top of your head, is 9. So now I know that my radius is 9. Again, I'm almost done. So here you don't have anything that you can count physically on a graph. I wouldn't waste time trying to graph it. It would be too complicated. So this is where you're really going to need that d equals 2r formula. And then I know that r is 9. So my diameter is 18. So again, the diameter is always twice the radius. All right, one more example and we are done. So looking at number 8, again, I'm going to write the formula down. So it's x minus h squared plus y minus k squared equals r squared. So before, we were only concerned with the x minus h, the y minus k when we were doing the center. Now I'm only concerned with the r. I need to know what the radius is. So I'm only looking at that right side of the equation after the equal sign, and I know that r squared equals 4. So just from that equation, I can pull out that information, and I know that r squared is equal to 4. Again, I'm not done. That's not my final answer. In order to get r by itself, I have to take the square root of both sides. On the left, it'll cancel, and I'm left with just r. On the right, the square root of 4, you could either plug it in the calculator, or maybe you know off the top of your head, is 2. So the radius is 2. And then to find the diameter, I have to plug the radius into this guy. So I know that the diameter is twice the radius, so I'm doing 2 times 2. 2 times 2 is equal to 4, so my diameter is 4. All right, and then this would be V2. So this is all finding the radius is V2. So I just wanted to take a second. If you feel confident, you're ready to start the IXLs, that's fine. I just wanted to take a second and show you how quickly you can actually move through this. So looking at this example, we have the center one. So this is V1. I want to find the center of this circle. So I want to know what this point is right here. Well, that point is at the origin. So it's 0, 0. That's my center. Done. Already out of 20. Again, I want to know the center of this circle. So ask yourself for the center ones. Is there anything being added to x? Is there anything being added to y? The answer to both of those questions would be no, there's nothing. Well, nothing is a number, right? It's 0. So this one, the center, would also be 0, 0. Done. Already out of 36. Looking at this one, so we want to know the center of the circle. So ask yourself, is there anything being added to x? Is there anything being added to y? There is something being added to x, right? It's 10. But I know that when I'm finding the center of the circle, I have to do the opposite sign when I'm finding it. So if I'm adding 10 in the equation, then that means my x-coordinate is at negative 10. Again, switching the signs. Is there anything being added to my y? No, there's nothing. That's still 0. Again, is there anything being added to x? Yes, I'm adding 2. So when I plug it in here, it's got to be negative 2. Is there anything being added to y? No, that would still be 0. Already out of 60. When you're at a graph, whatever that point is, it's done. You don't have to change the signs or anything because you know how to find a point on a graph. So looking, I'm going to the left, 1, 2, 3. It's at positive 3. And then I'm not going up or down at all. So my y is still 0. All right, so that already brought me to a 68. Now, really quick, I want to go through the radius one. So the same kind of concept here. So I want to know how long the radius is. So the radius extends from the center out to the edge. I'm always going to go horizontally personally. So if I count, that's just 1 unit. My radius is 1. Here they want to know the radius of the circle, right? And I know that this 49 is equal to r squared. So in order to get r by itself, I have to take the square root of 49. So I can plug that in here, or maybe you would know it off the top of your head, and that's 7. So my radius is 7. Again, what's the radius of the circle? I'm looking here. Now 16 is equal to r squared. To know what the radius is, I have to take the square root. So I take the square root of 16. That gives me 4. I want to know the radius of this guy. So I'm going over 1, 2, 3, 4, 5, 6, 7, 8. My radius is 8. Again, the radius, I'm starting at the center, going to the edge. I'm going over 1, 2 units. My radius is 2. Trying to find us a diameter one. Here we go. So now they want to know the diameter of the circle. So that's why it's important to pay attention to the directions, just to make sure that you're good. So the diameter of the circle. So first I need to know the radius. So r squared is equal to 36. To find the radius, I have to take the square root of 36. 6. So my radius is 6. I want to know the diameter, not the radius. In order to find the diameter, I have to take that radius and multiply it by 2. I get 12. So my diameter is 12. All right. So both of those guys, I want you to get to 80%. It shouldn't take you too long. You saw we got to like 68 in a couple of minutes on that center one. So just be careful with your signs. Be careful with whether it's asking for radius or diameter, and you should be fine. All right. As always, if you need help with anything, please let me know. Send me an email, send me a remind. Yeah, and have a great week.